Okay, so we have, here's everything for that first angle. Check, make sure that you got what I got. If you don't agree with mine, please let me know.
Are we supposed to put 10B into like
No, we leave it as an improper fraction. These ratios are always going to be just an improper fraction. Okay, do we agree with all those? Yeah, okay. And here's 2. Do you agree with all that? Okay, what did we notice? Anyone notice anything? Yep.
They all have their own formulas, like sort of formula things.
The opposite of hypotenuse, is that what you're talking about? Yep, Lily?
I noticed that sine A would be similar to cosine B, and cosine A would be similar to sine B, while tangent A and tangent B would simply just switch.
Very good. That's exactly what we were supposed to notice. That the cosine of A is equal to the cosine of B. Okay, so if you notice, here's my sine of A, it's A over C. Here's cosine of B, it's also A over C. Okay. She then said the opposite, which would be the cosine of A, then is also equal to the sine of B. So the two acute angles in a right triangle have similar sines and cosines. Okay, they're going to be related. They have the same ratios. Okay, and then she noticed that the tangent of angle A is equal to, I'm going to show you the algebra of it. It's 1 over the tangent of B. What that means is that the tangent of A is equal to the reciprocal of tangent of B. Oopsie, let's spell tangent. T-A-N. Okay. This is what it would look like algebraically. 1 over tangent means you're flipping it. Okay. This might be easier for you to understand, but on a test, it might look like this. Okay, and vice versa. The tangent of B is going to equal 1 over the tangent of A.
What if the after angle C?
Angle C, well, in this case, because angle C is a right triangle, we never find the trig of a right triangle. We don't say, or the right angle in a triangle. Because the opposite for this would also be the hypotenuse. So you couldn't find the sign because it'd be up, the opposite and the hypotenuse would match. Does that make sense? Okay. So you're only ever going to be asked for the acute angles, the two smaller angles. Any questions over that? We're good? Okay, so these things you need to know. These are trig identities. Those are kind of important. And I think on your THQ, there's one similar to this on there. Okay, what do you think these observations will hold true? Do you think these observations will always hold true? This isn't always things, yes. And the reason why we can say yes is in the first example, we use numbers to prove it. But numbers can sometimes be deceiving. Okay, so in example 2, we use variables. And since variables can equal any number in the world, we prove that to be true with our variables. So that's how you can prove something's true is using variables. Now part 2. They want to see if there's anything else that we can prove to be true. The following is a list of conjectures. Remember, conjectures is just like a hypothesis, just in math. Okay, so in math we say conjecture instead of hypothesis. In science you say hypothesis. It's your educated guess. For each state, whether you think the conjecture is true or false, justify your answer. Okay, so the sine of A, is that equal to the sine of A? Sorry, the cosine of A, is that equal to the sine of A? So let's see, here's A. Here's my opposite, here's my adjacent, here's my hypotenuse. The cosine would be B over C. The sine would be opposite over hypotenuse. So that would be A over C. Is that equal?
No.
No. Could it sometimes be equal? When would it be equal in my triangle? Very good. When my angles are 45 and 45. When my two angles are congruent, that means these two sides would be congruent, and A would then equal B, so that would work. But in this case, we don't know if what the angles are, so this would be false. Only if B equals A. Because the C already matches. So we'd have to have B and A be equal. Okay, tangent of A, is that equal to the sine of A divided by the cosine of A? Okay, we kind of already talked about this in one of our sections, I think in our cosine section. So let's prove that. The tangent of A in my triangle, tangent is opposite over adjacent, so A over B. Is that equal to the sine of A? Sine of A was opposite A over C, divided by the cosine of A, which was B over C. Now this is a complex fraction. Okay, you probably learned this last year in math too. Did you guys use the donut? Does that sound familiar at all? No? Okay. Well, I'll show you. This is AC is divided by BC. B over C. Does that make sense? When we divide fractions, what do I need to do? Multiply by the reciprocal. So this becomes multiplication, and I flip the second fraction. Then you just multiply straight across. A times C is AC. C times B is CB. Can I reduce? Can C go into C? Yeah, C can go into C one time, right? And I get left with A over B. So does this A over B equal this A over B? Yes. So this is true. And since we just use those variables, this is always true. Okay, so this is another trig identity. So I'm going to take it and I'm going to put it back on this page with all the others that we've already found. I'm going to say the tangent of A is equal to the sine of A over the cosine of A. Same with the tangent of B. Tangent of B would be equal to the tangent of, so the sine of B over the cosine of B. Okay. Next one. Do you know what the 90 degrees minus A is equal to? In my triangle, what would 90 minus A be? Angle B. That's all that states. 90 minus A, because the measure of angle A plus the measure of angle B should equal, oopsie, should equal 90 degrees. Because how many degrees are in a whole triangle? 180. And how many degrees are a right angle? 90. So 180 minus 90 gives me the 90 degrees. So I know that A and B have to add to 90. Any questions over that? We're all good? Okay, so what this is really stating is the sine of A, is that equal to the cosine of B? Yes, we already proved that. So this is true always, right? Okay, is the cosine of A equal to the sine of B? Yes. So it's true. Okay, cosine of B, is that equal to the sine of 90 minus A? What was 90 minus A again? Equals B. So this is the cosine of B. Does that equal the sine of B? What should it equal? The sine of A. Any questions over this? So this is false. Again, when would that be true? Very good. Only when the two sides are congruent. Okay, how about 10? Tangent of A equals 1 over tangent of B. True. We already proved that, right? Okay, so the following convention used to write. So usually, either the sine of A squared is equal to sine squared A. So these two things are equal. It's a little confusing, but that's how they write it. So they want to know if sine squared of A plus cosine squared of A is equal to 1. Okay, so we're going to draw just a regular triangle, makes it easier to deal with instead of variables. I'm going to put it over here. It's going to be a 3, 4, 5 triangle because it's easy to deal with. I'm going to label this A, this C, and this is B. And we'll see if this is true. So everybody find the sine of A and the cosine of A for me. Can you put your stuff down and just do the problem? Can you find this? Do you know how to find the sine?
Yes.
Okay, so what did we get for the sine? Daniel, what did you get for the sine? 3 over 5. So we're going to do 3 over 5, and then we're going to square it. Plus, Sam, what did you get for the cosine? 4 over 5, and then square it. Does that equal 1? Okay, don't use calculators. We know how to do this in our heads. Class, what's 3 squared? Okay, what's 5 squared? Okay, class, what's 4 squared?
16.
What's 5 squared? Okay, then we're going to 9 plus 16 is what? What's 9 plus 16? 25. The denominator stays the same. Remember, we just add the numerators. Does 25 over 25 equal 1? Yes. So this is true. Okay, this is again, another trig identity. So we're going to add it. Sine squared plus cosine squared equals 1. So we're going to put it back on this page so we have them all together. Okay, so would this be true? If I got the cosine by itself and I subtracted sine from both sides, would that still be true? Yes, it would, right? This is just solving this equation for cosine, right? So I subtracted sine from both sides, then this would work too. Does that make sense? Okay. In this one, is the sine squared a, is that equal to the sine of a squared? Okay, so this is sine a squared, we already determined was 3 over 5, right? Squared. Okay, let's pretend that this angle was like a 30-degree angle. Okay. So is that the same as the sine of 30 squared? Okay, because this would be, 9 over 25. This would be 30, would be sine of 900, right? Is that going to be the same thing? No. So this is false. Sorry, we should put true here too. So that one's false. This does not work the same way. To square the angle and then square the sine of that angle, that doesn't work. Yes. I don't have anything. I'm sorry. Oh, wait, hold on. Okay, on your homework, you're going to have to do a problem kind of like this. A right triangle with the following trig ratios. The sine of 30 equals 1/2. Find all trig ratios for this triangle. And how do you know these values are always going to be true when given this angle? So let's draw our triangle. Total regular right triangle. Okay, I'm going to say that this is 30 degrees. Okay, what is the sine? What is the side lengths? Sine is what over what? Opposite over hypotenuse. So if I have 1 over 2, what is the opposite of 30? So this is my opposite side, this is my adjacent side, this is hypotenuse. So the opposite side would be 1. The hypotenuse would be 2. How could I find the adjacent side? Easiest way to find the missing side of a right triangle. Pythagorean theorem. Okay, when I have 2 sides and I need to find the third side, I use Pythagorean theorem. So this is going to be my x. So I have 1 squared plus, this is a leg, so it's x squared, It equals the hypotenuse squared, so that's 2 squared. So 1 squared is 1 plus x squared equals 4. I subtract 1, and I get x squared equals 3. I take the square root of 3. So x is going to equal the square root of 3. Any questions over that? So now I can find all of the missing sides, or all the missing ratios. So I have the sine of 30 equals 1/2. The cosine of 30 is going to equal square root of 3 over 2. The tangent of 30 is going to equal opposite over adjacent, so 1 over square root 3. Now we need to find sine, cosine, tangent of the other angle. What is the other angle going to be? I heard someone say it. Very good. It's going to be 90 minus 30. Because these two angles add to 90. So it's going to be the sine of 60. Okay. And you don't even really need the triangle here. The sine of 60 is going to be the same as the cosine of 30, right? So the square root of 3 over 2. Then we have the cosine of 60 is going to equal the same thing as the sine of 30, which is 1/2. What about the tangent? Very good. Square root of 3 over 1, which is just square root of 3. Any questions over that? Okay, and how am I going to know that these are always going to be true when given these angles? Okay. We have our trig identities, right? Because we've already proven our trig identities.